All right, I'm going to do another induction problem. Skipping ahead just a little bit to 2d because that's a divisibility question, slightly different than the other ones. So question 2d looks like this. 9 to the n minus 1 is divisible by 8 for all, that's an 8, for all natural numbers. Okay, great. So first we plug in n equals 1, and we get 9 to the 1 minus 1, which is equal to 8, which is equal to 8 times 1. So it's definitely divisible by 8 because I showed that it was 8 times another integer. Then I assume 9 to the n minus 1 equals 8k. I'll just use the letter k for some k value that's a natural number. I could write integer here, but because I assumed n was a natural number, I'm going to get positive values, so I'm just going to write natural number. And then consider 9 to the n plus 1 minus 1 here. Okay, so at some point, what we want to do here is show that we can use the induction hypothesis in there. So let's look at 9 to the n plus 1. We can write that as 9 times 9 to the n minus 1. And you might be tempted to make a bad substitution. I cannot substitute this for there. Bad. Don't do that. But what I can do is take my induction hypothesis and rewrite it as this. 9 to the n equals 8k plus 1. So I'm going to use that because that's about all I've got to work with. So I'm not going to do the bad substitution. I'm going to do equals 9 times 8k plus 1 minus 1. Then I'm going to distribute the 9. So I guess well, what am I trying to prove? It's divisible by 8. So I guess I don't really need, I know it's 72. I don't really need to know that it's 72. I can just write it like this. 8 times 9k plus 9 minus 1. So I'm still distributing it. And I'm doing it in a slightly weird way because all I really care about is proving that it's divisible by 8. So it's actually kind of nice to leave the 8 there obvious because then I can do this. 8 times 9k plus 1. And that is divisible by 8. So we are done. So 9 to the n plus 1 minus 1 is divisible by 8. So we are done with the proof by induction. We proved that it was true when n was 1. We proved that if you assume that it's true for a particular n value, that it must be true for the next n value. And then putting that thought together means the first proves the second, proves the third, proves the fourth, all the way up to infinity. And that's it. So please comment, ask questions, whatever you need to help you get this induction stuff down.